In this video, I'm just going to do a few example problems using the definition of logarithms and a little bit of the change of base formula. I'm going to start off just by finding inverse functions. So for this first problem, I have my function f of x is 3 times 5 to the x minus 7. I want to find the inverse function. Just bear in mind, this is an exponential, so my inverse function should be a logarithm. So again, when I'm trying to find an inverse function, I mean I need to switch x and y. So I'm going to take this, and here would normally be my y, so I'm going to rewrite this problem as x equals 3 times 5 to the y minus 7. And here's my exponential here. I got to solve for it before I can do anything else. So I'm going to get rid of the 3. I'll divide both sides by 3. X over 3 equals 5 to the y minus 7. And now, this is an exponential form. I don't know what to do with it. My variable's up here in the exponent, and no way to get that out of there. So I'm going to switch over to logarithmic form. So I'm going to say my base is 5. So I'm going to have the log base 5. My output was x minus 3, so this is now my input. My input is y minus 7. That's now my output. I switched to logarithmic form, and now I can deal with this. So I can just add 7 to both sides, and I get the log base 5 of x over 3 plus 7 equals y, and that's my inverse function. F inverse of x log base 5 x over 3 plus 7. And it makes sense because my exponential was base 5, my logarithm is base 5. That should happen. Keeping up with the finding inverses, I'm going to go the other way around. I'm going to start with a logarithm function. In this case, I'm giving you a natural log. And remember, natural log is the log base e. So, again, I'm going to rewrite this, switch my x to the y, and I'm going to get x equals 5 natural log of y plus 1. To solve for y, I'm going to start just by getting into a log. To get into the logarithmic form, I need to solve for the log. So I get x over 5 equals the natural log of y plus 1. And again, this is exponential form. Sorry, it's not exponential form. Duh. Okay, try this again. It's logarithmic form. I want to put it into exponential form because I'm in the middle of a log. I can't deal with it in the log. So it's natural log. That's the log base e. So I'm going to say, don't move. E, my output was x over 5. So that's now my input, x over 5. And my input to the logarithm is now my output. So I get y plus 1. Subtract 1 from both sides. And I get e to the x over 5 minus 1 equals y. There's my inverse function. F inverse of x is e to the x over 5 minus 1. That's what we're doing. Pretty much getting down to when we're finding inverses is get it down to the exponential, switch to log form. Get it down to the log, switch to exponential form. Now let's use this to solve an equation. This case, 5 times 2.43 to the x plus 1 plus 7 equals 142. Again, here's my exponential function. My variable's up in the exponent. I can't deal with it there. To get it out, I need to switch forms. To do that, I need to get solved just for the exponential. So I'll get rid of everything else. So we'll subtract the 7. And we'll get 135 is 5 times 2.43 to the x plus 1. I'll divide by 5. I get 2.43 to the x plus 1 equals 27. And this is an exponential form. I have a base to a power equals a number, so I'm going to switch it over to log. I can't do anything more in this form, so I switch forms. I have the log base 2.43, because again, there's my base. My output there is 27, so that's what I'm taking the log of. The log of 27, but it's base 2.43, equals x plus 1. So x is going to be the log base 2.43 of 27 minus 1. Now, to get that value, I'm going to use my change of base because I don't have log base 2.43 tables handy. So I'm going to take that to be the common log of 27 divided by the common log of 2.43. Remember, I take the log of the input divided by the log of the base. I subtract 1. And when I do this, I will get about 2.712. Now again, I really suggest you're solving the equation, you get that answer, 2.712. You should be able to plug that in for x and get approximately 142. Now we did round, so we might not get there exactly. But anytime you solve, you should be able to do that. This idea of solving equations just comes down to get it down to exponential form, switch to log form. Or get it down to logarithmic form, switch to exponential form. If you can't deal with it in one form, switch it to the other. Now comes the real fun. Here comes our story problem. Daisy knocked the ball off a counter. On the second, she was watching it bouncing on the second bounce. Notice it got up to 0.8 of a meter. On the fifth bounce, she noticed it got up to 0.6 of a meter. And wants to know how many bounces will it take to only reach a bounce height of 0.1 of a meter. So here, we have to write the equation before we can even solve it. So that goes back to what we were doing before break. That's what was happening in the first half of the chapter. So we take a look at this, and our variables, our input, our output, are going to be the bounce and the height. So we have second bounce 0.8, and we have fifth bounce 0.6. With this, we can write our equation, and we're going to use that point ratio form. So we're going to say y equals, I'll use this point here, y equals 0.8 times my b to the x minus 2. Now I'll plug in the other form in for x and y so that I can solve for b. So I'll get 0.6 is 0.8 times b to the 5 minus 2, and solve this equation for b. So I'm going to divide by 0.8. That's going to give me 0.75. I can take 5 minus 2 is the third power. So b is going to be 0.75 raised to the 1/3 power, which is approximately 0.909. So my equation that's going to model this situation, from here I'm going to plug in my b value, and I will get y equals 0.8 times 0.909 raised to the x minus 2 power. And now I'm ready to start my problem to solve. Okay, this is all what we were doing before. But now I need to get a bounce height of 0.1 meter. So that's my y. My height is my y value. So I have the equation 0.1 equals 0.8 times 0.909 to the x minus 2 power. Now I have an exponential equation. I got my variable up in the exponent, so I want to solve for my exponential function. Switch to logarithmic form. So I'll divide by my 0.8. I'm going to get 0.125 equals 0.909 to the x minus 2. And here I'm exponential. I'm going to go log. So I'm going to say the log base 0.909 of 0.125 equals x minus 2. I can have a base that's a decimal. It doesn't matter as long as it's not 1 and it's greater than 0. So my x is going to be the log of base 909 of 0.125, and then we're going to add 2 to that. So back again to our change of base formula. Our friend, really. X is going to be change of base formula. We say the log of the input, 0.125, divided by the log of the base, 0.909. And then I'm going to add 2 to that, and I'm going to get x is approximately 23.79. So I'm going to say the 24th bounce. Type of things we expect you at this point to be able to do. Find the inverse function. That involves switching from exponential to logarithmic form, or vice versa. To take an equation, if it's in exponential form, we're going to solve for the exponential and switch to logarithmic. If it's in the log, we're going to find the log form, and then switch to exponential. Get it to the form that you can solve it with.